Hello everyone. Thank you again for joining today's webinar. Today the webinar is on BLiNQ Networks. That's on the 4G and 5G solutions. As you know, Xtream is in the industry, wireless networking industry since 2016. So recently we have partnered up with BLiNQ Networks. So their headquarters are in Canada. So all the manufacturing process will be done in Canada and USA. So if you have connected with Xtream, you know we will have a webinar once a month. So today we thought to come up with BLiNQ Networks. From BLiNQ Networks, today we have Mr. Patrick Boothman and Mr. Andrew Loftus. So they will be joining as trainers. So Mr. Patrick, over to you.
Okay, thanks for cheating. My name is, as she said, is Patrick Boothman. I'm the Vice President of Business Development for BLiNQ Networks, based here in Toronto in Canada, and just wanted to present some of our solutions on the private 4G and 5G side of the market. If you have any questions, feel free to ask them in the chat panel, and we'll try to get as many of your questions answered as we can during the course of this webinar. So a little bit about BLiNQ Networks. We started off, we've been focused, it's a very much a radio and RF focused company for the last 13 years that we've been in business, and we specialize almost exclusively in LTE and so 4G and 5G ready access solutions in terms of low cost small cells. Company was founded in 2010. Originally, we were doing small cell backhaul with a product called the X1200i. Did point to multi-point beamforming, did a lot of projects like that with Vodafone, AT&T, and America Mobile in Mexico. And then in 2017, we pivoted over more towards the access side of the network and started actually just building the 4G and 5G small cells directly to enable, private 4G and private 5G and rural fixed wireless access type markets. One of the things that's been fairly unique about BLiNQ is we like to build solutions that are fully integrated, even outdoor macro cells that are fully integrated. So antennas, baseband, radio, all combined into a single unit, and generally, very portable and very easy to deploy and operate. For example, our FW300, one of which we, was our X300, both of which we were trying to show off at GITEX a couple of months ago. And the idea behind the X300 and the FW300, for example, and the 4G side is that they were fully integrated units, antennas, baseband, everything. So really, basically a private network in a box. A little bit about the team. The key team that is involved in BLiNQ Networks, myself included, plus the CTO, VP of Operations, we were all part of Redline Communications. And so we had originally been building and deploying WiMAX solutions back in the mid-2000s. And then also additional folks coming from Cisco and a couple of large operators, Rogers in Canada and Bell in Canada as well. We are very heavily focused on the radio aspect. So generally the idea being is that as a team, our objective and our mandate as BLiNQ as a company is to build the best radios in the industry. All design and development is done in Toronto, or we have a satellite office in Ottawa, which is about 4 hours down the road from Toronto and Canada's capital. And between those two, all of our hardware, software, engineering, design, development, R&D is done. Because we are a relatively small team and we focus heavily on our customers, it allows us to design unique solutions for customers and turn things around very quickly. All technical support's done out of there as well. So it makes it very easy for us to be able to keep up to date and provide unique solutions to customers, respond to their needs quickly, things like that. So a little bit about the company itself. BLiNQ was started in 2010 in Canada. We were acquired by a company called CCI Products, who is based in New Jersey, in the U.S. In 2016, and we've basically kind of migrated or merged those two teams together. So there's a couple of facilities that they have in New Jersey and in Seabrook in New Hampshire, which provides some additional engineering resources for us, and we also use them occasionally from an antenna development perspective in terms of integrated or third-party external antennas for certain products that use external antennas out of their Ottawa research center. And then BLiNQ's offices are the ones that are shown on the right-hand side. So a little bit about some of our customers, some of which are large mobile operators, predominantly on just the antenna side itself. So things like AT&T, Verizon, Rakuten, Dish, T-Mobile, EE, Airtel, Reliance Jio, Singtel Group, etc. Some of those are some of the large operators that we've been selling antennas into for many years. Also from a large fixed communication operation in the U.S., Frontier Communications and Watch Communications, both of which are large fixed line operators in the U.S. that we've done work for them as well. Plus a number of smaller regional service providers, Kansas Broadband, Sky Fiber, Point Broadband, and a company called Broadband One. A number of those that are the smaller players that we sell to in the U.S. and elsewhere. We've also done a lot of work in private 4G, private 5G through the pandemic with educational institutions such as Phoenix Community College, Phoenix Unified School District, the University of Buenos Aires in Argentina, I think it's Midvale School District or Murray School District rather, in Utah, which is one of the largest school districts in Utah in Salt Lake City. And we also do a lot of work with various industry verticals as well. Companies like Caterpillar, John Deere, Thales Transportation, who do trains using connectivity using our systems. And then one of the new ones are some of the decentralized mobile operators, Pollen Mobile, XNet Mobile, Carrier One, and World Mobile, and Really are some other ones that we do a lot of work with in the what's called the decentralized wireless operators. When we look at 5G, one of the things that really makes us unique is we're pretty much the first company in the world on the 5G side that has looked to actually integrate 5G and Wi-Fi, Wi-Fi 7 that is, into a single unified platform in a single box that you can be deployed in an enterprise environment, and to be able to incorporate both of those into a single unit. What's also critical about that is you can really optimize your spectrum utilization between using the 5G spectrum that you have and Wi-Fi, including the 6 gigahertz band, to make sure that your end user devices, your customers' devices, are optimally connected at any point in time to the right spectrum and the right radio technology to be able to maximize their use and their performance, and to be able to actually hand traffic from one form to the other, and even be able to actually utilize one band or the other for connectivity, even potentially in a mesh type of environment. So you could deploy a number of private 5G BLiNQ small cells, say in a warehouse or a factory, connect them over the Wi-Fi 7, so the backhaul would be done by Wi-Fi 7 between boxes, and then the private 5G network using your 5G frequencies, such as 3.5 gigahertz, for example, as your access technology, meaning you only need to deploy power to these devices, and you don't actually need to provide any fiber backhaul if it's a complicated factory or warehouse, particularly one that's well established and not easy to necessarily place devices exactly where you want them. We use EdgeQ on our 5G products as the chipset So EdgeQ is a brand new company out of California, and so they really have the chipset that actually allows us to be able to do this, unique devices. And the other thing that's very interesting about it as well, it's a very, very efficient chipset. So power consumption remains very low overall within the unit compared to a lot of our competitors. And that's even without our competitors doing, a mix of 5G and Wi-Fi in a single box. We can do both and still maintain very low power consumption. From an architecture perspective, we're very flexible as well. So we view ourselves sort of as a Switzerland, if you will, of the connectivity of the 5G and 4G connectivity world. So we work with a number of different packet vendors, packet core vendors, things like Druid, Adacore, Athonet, even Nokia, Ericsson, Cisco. And also one of the other things that we do as well is we can integrate into both an Open RAN environment, for example, and turn the small cell effectively into just simply an RU and work with other CU and DUs. Or we can run it as a fully integrated unit where RU, CU, DU are all fully integrated into the BLiNQ solution and actually be able to just operate as a fully integrated standalone small cell. Also, we work with distributed type packet core solutions such as Adacore and others, or completely cloud-based centralized solutions, things like Druid and other solutions like that. So a little bit about what we have from a 5G product perspective. Starting in the left-hand side is a PC400. So this is basically an indoor small cell unit. It's about the size of maybe a dinner plate, a traditional dinner plate, about that size, and about 2 inches thick. Designed to be, ceiling mounted. It's 4T4R, so 4 transmit, 4 receive, in a single cell, or it can actually run in 2 separate sectors of 2 transmit, 2 receive in each one of those sectors. So you've got the ability to do all this via software to either operate the unit as a single 4T4R or 4x4 MIMO small cell, or as 2 separate 2x2 MIMO small cells, for example, in say 2 different channels within 5G bands, to be able to operate like that. Up to 200 megahertz of channel bandwidth in 5G, and up to 4 component carriers potentially added together depending upon what sort of configuration. So you're looking at capacity and throughput in excess of 2 gigabits per second on the downlink side, and 500 plus megabits per second on the uplink side. Also, again, optional add-in Wi-Fi 7 as a module, and that supports tri-band, so 2.4 gigahertz, 5 gigahertz, and 6 gigahertz, all of which in a 2x2 MIMO type of an environment. Moving to the outdoor side, we've got the PCW400i. This is very similar to our FW300 in the 4G environment, and it's an outdoor small cell. And what you'll actually see on the screen here is this unit on the right is a fully integrated unit, and it can operate standalone as a 4T4R, so 4x4 MIMO small cell, or you can actually pair it with an external antenna, which is what you see on the opposite side, and then turn this into a 2T2R or 2x2 MIMO small cell, and then run a separate radio just by connecting into there as a separate 2x2 MIMO or 2T2R radio on the other side. So you can go from, say, 180 degrees of coverage in a 4T4R small cell, and if you need to add more capacity or more coverage to the other side of a tower or pole, for example, you can actually then just add on that external antenna and actually double your coverage and then have a 2x2 MIMO system on either side, or one single 4x4 capacity system on one side. And finally, on the outdoor side, the outdoor micro, that one's a 2025 deliverable. This is really designed for the larger operators and the larger outdoor deployments. This is a non-fully integrated solution, as in it will work with external antennas, but all the same capabilities exist. So this is a dual 4T4R. So what this has is powers two sectors, each of 4x4 MIMO, carrier aggregation up to 400 megahertz, and up to 4 component carriers at any point in time. So now you're really talking about, again, multi-gigabit per second capacity out of the network, out of a single cell, basically connected via 2.5 gig or 10 gig fiber connectivity into the box. And even potentially has the option to support both a 5G NR radio and an LTE radio simultaneously. So you could end up operating an LTE radio in 4x4 MIMO and a 5G NR radio in 4x4 MIMO simultaneously, if you happen to have customers that don't have 5G radio coverage or 5G radio devices that are necessary. So a little bit more about the indoor PCW 400i that we first talked about. Again, this one is the unit and basically some heat maps of some testing that we've done in and around the offices. So you're looking at large coverage and capacity, and if we see here, this is your signal to noise ratio. So anywhere in 30 is obviously very hot and a good clean signal. But even towards the edge of buildings, you're still being in the 10 to 20 dB of signal to noise ratio perspective. So still very good coverage throughout even the corners of the buildings, for example. Again, the differentiation for us is that this is a unified 5G plus Wi-Fi solution, which nobody else has really come out with in the industry so far. As we are radio experts, again, provides excellent coverage, and that's a primary focus for us. All of your traffic management and network management is done out of a single platform. So fully integrated Wi-Fi and 5G coverage and optimization, and prevents the need for additional cabling. So it makes it much simpler for end customers or operators to deploy for their end customers in that case. Really, the target markets for something like this is, the enterprise private 5G type of an environment, warehouses, shopping centers, anywhere in an indoor environment, factories where they want to get coverage in those, hard corners and need places to do. They've got lots of automated machines moving that need coverage, and traditional Wi-Fi has not been reliable, those types of things. So it's a little bit about what the unit looks like. So it's just 275 millimeters wide, 275 millimeters, deep, and then or height, and then 95 millimeters thick. But that's the unit. Exactly what it looks like right there. You can see that over here, Ethernet port for 2.5 gig Ethernet and SIM card slot. The PC400. Outdoor picocell. So this again is a closer view of this particular unit right here. So this is the actual radio itself, seeing with connectivity. By the way, this unit here is power over Ethernet. So it's PoE powered in standard power over Ethernet type configuration. So single cable is all you need for deploying. This unit's obviously not necessarily power over Ethernet, but so this is your PC400 unit, and integrated antennas here. Again, this unit on the right hand side can be operated in a 4T, 4R type configuration, standalone by itself, or you connect the external antenna ports, and then this radio can be actually utilized in 2R, and this antenna on the other side would be another 2T, 2R, 2x2 MIMO type configuration to double your coverage and split the cell, if you will. So effectively in a dual cell 2TTR type environment, you're looking at about 2 gigabits per second of downlink capacity with the PC400 in a 5G type environment. The MC800, which is a 4-sector microcell in a box. Now this offers a number of different deployment methodologies as well. So you can do dual cell 4T4R, as I mentioned earlier. So you can run 2 antennas off of it, each one at 4x4 MIMO, for example, and do back-to-back coverage in that particular environment. Or you could even potentially deploy it in a 4 times 2T2R type environment. So you do 4-sector coverage. So you'd have 2x2 MIMO here, 2x2 MIMO here, 2x2 MIMO here, and 2x2 MIMO here. So you could do a 4x90 degree type setup out of a single radio, and very high capacity coverage out of any single tower, for example, to be able to do very high capacity and very good coverage through that entire device. This product's not available again until 2025, but it is a full power macro outdoor base station. You can see which bands we support in the plan: N48, N77, N78. We can look at doing other bands as well in the 5G bands, based upon demand, but we'd really need to see what customers come to us and say which ones they want to support. But this is typically your 3.5 gigahertz. So basically you're looking at from 3.3 all the way up to potentially 4.2 gigahertz bands that we're supporting for that product. The overall network architecture, really where this comes in, and some of the unique things that we are doing is, if you see the radios on the bottom, and this is your radio access layer, there is the 4G or 5G packet core that exists in the middle, and then spectrum allocation in the top left-hand corner, whether that's AFC as a requirement in the US and elsewhere from a 6 gigahertz perspective, or a spectrum allocation service for CBRS in the US, which is not so applicable to the rest of the world. But still, one of the critical things from a management perspective is really twofold. One of which is managing the devices themselves, whether that's radios or end user CPE, for example. Those are critical things. You need to know what the status is, what's going on with the network, what devices are connected, who's transmitting, who's receiving, what kind of performance they're getting, etc. But you also need to know what kind of spectrum everybody's using, and how do you manage that, the control and access of that spectrum to ensure that you've always got kind of the cleanest, most efficient use of spectrum that you can get. So we've actually built our own spectrum controller and effectively a self-operating or self-optimizing network solution within this. And we're really combining our network management platform and this self-optimizing network element of it into a single system. It's called NetLink. And this is our basically overall management platform, completely modular, cloud-based, that can be used to monitor and manage, control, configure, and optimize the network on a continually ongoing basis. So the spectrum controller, the things it does is it basically is always constantly ensuring that your devices have access to spectrum. One of the challenges that has certainly happened with SAS in the US, and maybe a challenge for customers working on this in the 6 gigahertz band in Wi-Fi, is as in an outdoor environment, automatic frequency coordination, or AFC, starts to become critical. And the challenge with AFC is that as other devices come up and other people start to use that network or that spectrum, then you may have customers that are actually, potentially interfering with each other. What the spectrum controller does is it actually will, constantly be on the lookout to see what other customers are coming up in the area, and ensuring that, the BLiNQ radios constantly have the most optimized spectrum available for their usage, to ensure that your customers don't go down and don't have disconnections or lack of spectrum available for the radios themselves. And then within an enterprise itself, ensuring that you've got optimized Wi-Fi and 5G coverage within the environment, so that to ensure that you're not interfering with each other, you can switch channels as needed to ensure that the network is the most optimized by itself, depending upon how things are deployed within a system. So much like a controller-based Wi-Fi network, such as something from Cisco or Aruba or Ruckus, for example, the same kind of functionality happens in a private 5G and Wi-Fi environment, but covering both private 5G and Wi-Fi. So unlike solutions from some of the big Wi-Fi vendors like Cisco or Aruba or Ruckus, we actually coordinate and consolidate and control and optimize that spectrum, both on the private 5G side and on the Wi-Fi side, all within a single platform, as opposed to non-integrated solutions that may come from Cisco and Aruba and others that do not coordinate between the Wi-Fi and the private 5G side. Of course, the ability to do 5G end device monitoring, management, interference management, overall sensing of what's happening in the environment. You can detect, weak areas of coverage, things like that. And most critically, it's a single pane of glass or a single window for management into both your 5G and Wi-Fi networks within the entire installation. Another critical element, of course, is zero-touch provisioning and installation. So effectively, what you do is you introduce those devices into your network, and you say these devices are going to be joining the network. And when those devices join into the network, they're plugged in. They'll actually go to NetLink, download their configuration and their profile, and automatically start transmitting. So you don't need to individually configure each and every device. You can go into the NetLink interface, configure all the devices in advance, and then when you deploy them, all of those devices just simply get their configuration from the network themselves without having to be configured individually on a one-by-one basis. And some of the cloud building blocks that we're doing from a NetLink perspective, really, and that's an actual view of the screen on the left-hand side. You've got your traditional network management solution in itself. A single dashboard that looks at the G-Node B, the UEs, application performance, Wi-Fi, UPF, your typical management and monitoring that's carrier grade to handle this, your interference monitoring, and diagnostics, for example, of the actual devices themselves. Then there's the spectrum controller. It's your dynamic spectrum management piece, again, optimizing your 6 gigahertz and your 5G spectrum, for example, if you're in an environment like with a shared spectrum model like CBRS, for example, and ensuring that, in the case of CBRS, PAL and GAA spectrum management is handled, and including things like backhaul. So if you're potentially using the Wi-Fi 7 6 gig interface for backhaul in a mesh type of a deployment, it will optimize the spectrum to ensure that you're actually getting, peak bandwidth from a mesh deployment perspective as well, and not just on the access side. And then finally, EasyLink. This stuff is pretty cool. So basically what we're doing from an EasyLink perspective is it's proactive, and it's actually AI and ML powered module that does advanced trend analysis and diagnostics. So what it really allows you to do is actually start to look at overall trends and actually make predictive analysis or even predictive troubleshooting type steps. So even though something hasn't failed yet, BLiNQ can actually potentially look and say, you may have a radio that's failing because we've noticed these additional issues along the way, or things like, hey, we may have noticed that, an BLiNQ can start to report in and say, we've noticed connectivity problems in this particular area of the network. Mr. Network Operator, you may want to take a look at what's happening in that area. Did something change because we're starting to see a lot of interference or poor coverage or dropped calls, dropped connections, all of those kind of things, and can actually produce a proactive report on a regular basis that actually will tell the operator and the management of the network what's going on at any point in time, and offer some solutions as to what may be happening. So truly a unique use of AI and machine learning to do proactive network health monitoring and management, rather than simply raising an alarm that says, oh, hey, something failed. Go take a look at why this radio is down. It can start to tell you that a radio may fail before the radio has even actually fully failed. And some of our 4G product line, some of which was on display at the FW or at the GITEX show last month in Dubai. The X300i on the left-hand side, we've got those labels wrong. I need to fix those. This one is actually the X300i on the left-hand side, and it's about a foot tall, 30 centimeters, fully integrated indoor-outdoor small cell, 3 sectors. Common baseband antennas, radios, everything built in. Just plug in a cable and connect it to a core, and you've got a small little network in a box. Very simply done like that. All 4G. The FW300 here in the middle, that is the about the size of a small carry-on suitcase, and it is a 3-sector fully integrated outdoor macro base station designed to work in 3.5 gigahertz band. So no Wi-Fi solutions integrated with these units, for example. But in the FW300 here in the middle, it is a fully integrated solution, provides 180 degrees of coverage, 3 sectors, each one 60 degrees, and supports carrier aggregation and combining of sectors together for higher capacity in any one individual sector. And this has probably been our most popular product overall, that's being deployed heavily by both the DY market, the decentralized wireless market, and a lot of fixed wireless operators within the US. On the right-hand side, our FW600 looks an awful lot like the MC800, and they will actually share probably the same overall industrial design and mechanical design. This is a compact outdoor macro cell, again about the size of a larger briefcase, but it utilizes external antennas, and very similar to the FW300 in that you can connect and orient multiple antennas in multiple directions depending upon how you need to do your network. So you could do 3 by 120 or 3 by 65 or 3 by 90, for example, to provide the coverage that you need and want throughout a particular environment. So it's very flexible in terms of deploying from a cost-effective perspective. So you can really optimize your coverage and capacity as needed depending upon what type of environment you want to deploy. And that's BLiNQ Networks in a nutshell. Do we have any questions? We do not have any questions so far. Are there any questions from anyone?
Yes, everyone, if you have any questions, this is the time.
There is a question of, will there be a record of this webinar? I think there will be.
Yes, It's recording and we will send you later.
Yeah, I believe we can make the slide deck available as well. So. Slide 9 PCW. Sorry, PCW and slide 9 signal and noise in coverage zone. Are there 4 antennas used? Let me take a look at which one that was. A second. Slide 9. You're talking about, yeah, this was slide 9. This was actually, Igor, to answer your question in this particular environment, this is actually 2 integrated units, so 2 of these. So these are operating in, so there's only 2 small cells deployed in the offices in this particular environment, based upon how that's done and what's measured. So it's not there's not 4 antennas used. It is, from a coverage perspective, there are multiple antennas around the outside edge of each one of these radios. So if we take a look, don't have the structure on the inside, but effectively we've got antennas throughout the outside edge, sort of in a quasi-omni type of a deployment. But that's how it gets coverage out of this, actually, is so you've got coverage in all 4 directions, all 4 compass directions from each one of these. But this deployment that we're showing here is actually 2 radios, each one that does effectively, 4 sector deployments, or 4 directional coverage in that sense. So, but it's not really 4 antennas, if that answers your question. So you're asking, Mohammed, you're asking about the encryption method. Encryption in what sense? So encryption from a backhaul perspective follows 3GPP standards. So that's typically done as either IPsec or WireGuard for encrypting your traffic back to the tunnel. If that's what you want to use, is either IPsec or WireGuard for encryption on that. Over-the-air encryption is handled again as a 3GPP standard using SIM cards, etc. So that's all completely standards-based 3GPP type solution. As to cost, you'll have to talk to the folks at Xtream for pricing. So we will get pricing to them on the 5G products. They have pricing on the 4G products already. We'll get pricing to Xtream on the 5G side, but they will be able to provide pricing for you on that one. Sorry, you're asking a question, Igor. 4 plus 4. In the case of the PCW 400 that we showed, each one of those radios is a 4x4 radio. There are multiple antennas connected, for example, but the unit has the ability to operate, so all the antennas are connected to the same device, so you can actually kind of split signal between the different antennas depending on how it works. So there's an RF switch inside, so effectively you can operate as 2 cells of 2x2 or 1 cell of 4x4 using all antennas in a 4x4 environment, or in 2x2 operations, and then each side will use 2 antennas, for example, in that particular case. Yeah, that's exactly it, Igor. There's in that slide 9. There's 2 base stations, with each with the 4 equipped antennas. That's basically correct. Yes. There was another question that popped up and then dropped off. Okay, so actually that got answered. So, yeah, Ali, on the license frequency, it really depends upon the local operators. Now, a number of countries, particularly, are seeing this in the European Union now, and I expect we'll start to see this in parts of the Middle East and Africa as well, are starting to actually allocate frequencies for private 5G environments. So typically, what we've seen in the UK and Germany and the Netherlands and France, they are offering similar to CBRS in the US, which is 3.55 to 3.7. They are offering frequencies in that mid-band 3.5 gig spectrum, specifically for the private 5G environment. So Germany offers 3.7 to 3.8. So I suspect we'll start to see some of that take place in the Middle East and Africa as well, allowing for the availability of spectrum to be used by private enterprises for private 5G. So I expect we'll start to see some of that soon, as that's really grown from the US now into Europe, and I think we'll probably start to see some of that in the Middle East and Africa as well. Igor, yes, for your question in slide 12, that is showing 2 4x4 antennas connected in that environment. Yes. So, Ali, for your question for designing such a network, do you need RF planning tools? Yes and no, but I think it really depends upon the environment. So from an enterprise environment, for example, if it's going to be a private 5G deployment, you really probably don't need a lot of RF planning tools. Netlink and the Spectrum controller will take care of a lot of those particular tools for you. But one of the things that we can do is we do offer RF planning services from BLiNQ as well. So that will be something that can be done through Xtream, is the ability to actually do some high-level RF planning, particularly for initial deployments, readily in that sense. So you don't necessarily need to acquire tools of your own. Those skills and those resources can be provided to you, depending upon the size of the network and what you want to entail from there. Mohammed, you have a question about more details about the controller. What would you like to know about the controller, the Spectrum controller? And yes, we have a number of technical resources. So if you have particular technical questions that you would like answered, feel free to reach out to the Xtream team. They will, and then put you in touch with our deeply technical resources that will be able to actually answer any questions that you have. So, Ali, for your question on deployed cases, can you give a committed information rate SLA to customers like VSAT or no? So typically our deployments are kind of the other way around. VSAT becomes the backhaul, and the BLiNQ equipment, the G node B or E node B, would be the access side. So we wouldn't necessarily be giving a CIR to VSAT. So I guess I'm trying to understand if you're looking at it from the other way of, if VSAT gave us a certain amount, would you be giving a committed information rate to the end user customers that are connected via VSAT? Because VSAT would probably be the limitation in those particular interfaces rather than the BLiNQ equipment being the limiting factor. But you can do it. I mean, within the system itself, you do have the ability, provided that the link is good enough. You can absolutely define CIR and quality of service type parameters that you can offer up to solutions, up to end user customers, assuming that the link budget of the end user devices have the ability to do so. You can absolutely specify within the system that these customers are gold customers, and these customers are platinum customers, and these customers are bronze customers, and the priority and the quality of the service and the CIR gets allocated towards the platinum and the gold customers, and not the bronze customers. Any other questions, folks?
I believe there's no more questions.
It does not look like there are any more questions.
Yeah, Mr. Patrick, I think we can wind up the session. So
Okay.
thank you so much for conducting the webinar today. And all the participants, thank you so much for allocating your time. And if you have any inquiries, any questions, please get in touch with us. Please send us an email, sales@xtream-me.com. That's our email address. So you can contact us. So thank you so much all, and see you in the next webinar soon. Bye.
Thanks everyone for your time.